Hello and Assalamu alaikum. My name is Fakisha and in this video we will be doing implementation of Boolean functions and verification of De Morgan's law using gates integrated circuits. First we will be discussing De Morgan's law and then we will verify it making logic circuit in Proteus and simulating our results. So what is De Morgan's law? According to Wikipedia, in propositional logic and Boolean algebra, De Morgan's law are a pair of transformation rules that are both valid rules of interface. So, we will see this law and verify it in Proteus, and now we will be moving on designing our circuits. So after designing the circuit, we will see the simulation, either the De Morgan's law verify or not. So we will start the simulation and see. As you can see, on both the inputs are 0, that is x and y, and here we have a and b. Our output is 1. Our output is 1. That means our bulb LED are glowing. So if we change any of these gates, if any of these inputs if we close the gate, close the inputs, so you will see that the LEDs will switch off and our output will be 0. So in this table, as you can see, the y is 1 and x is 0. So you will see this by closing the gate B. So both the outputs are 0. So if I open this and close this one, still both the output are 0, as you can see in this row. So if both the inputs are 0, the outputs are still 0. Now we are heading towards our second De Morgan's law circuit. So in this equation we have uh, when a and b multiply and their whole conjugate is equal to a conjugate plus b conjugate. So we will see, so you can see as when both the inputs are 0, both the inputs are 0, that will get the input, the switches are open, both the inputs are 0, we'll get one output. So our LEDs are glowing, which means our output is 1. So if I close any one of these, if I here it close y, I close b, still the output is 1, which our uh, table shows the output will be 1. Similarly, if I open this one and close this one, still our output is 1. So in this way, the circuits are working greatly. Now we will moving towards our implementation of Boolean function circuit. So here I have this truth table for this circuit. So we will saying when both the inputs are when there are three inputs in the circuit, and we will see when both as you can see the simulation is running, and both the inputs are 0, the output is 0. So here it closes the z gate. I close the z gate, still the output is 0, as you can see from the table. And if I open this one and close the y1, still the output is 0. But if I close both y and z, the output is 1. I close y and z, my x is open, output is 1. So my LED is glowing. So if I open these both two and close the x, my output is 1. Close, my output is 1. So if x is closed and z is closed, gate, the output is still 1. X is closed, z is closed, output is 1. And if x and y are closed, the output is still 1. And when all the three gates are closed, we get the output 1. So in this way, our circuits are working perfectly. That was it from this video. Thank you.